Now in this question we're asked to solve the differential equation 2 cot x dy dx equals 4 minus y squared. We're given that y equals 0 when x equals pi upon 3. And our answer's got to be given in the form sec squared x equals a function of y. So how do we start to do this? Well, first of all we need to separate the variables, that is, put all the y's on one side of the equation and all the x's on the other. So if I do that by dividing both sides, say by cot x and 4 minus y squared, and moving the dx, what we have is 2 all over over 4 minus y squared, okay, dy equals 1 over cot x, okay, dx. Now we need to integrate both sides. Now to integrate 2 over 4 minus y squared, I need to split this into partial fractions. And this was done earlier on. So what we've got is that this becomes the integral of 1 over 2 times 2 minus y plus 1 over 2 times 2 plus y. Alright? A couple of terms here in this integral, so we need to put some brackets around that, and we have that integrated with respect to y. Now when it comes to 1 over cot x is 1 over tan x, so simplifying this term becomes the integral of simply tan x with respect to x. Now to integrate these, what I'm going to do is pull out this 2 that you see here, so in other words pull out a half as a common factor. You don't have to do this, but I feel it makes the question a lot simpler to do. I always get in the habit of pushing out constants in front of integrals. So we have 1 over 2 minus y plus 1 over 2 plus y, and that's integrated with respect to y. I'll leave this integral just for the moment, okay, so we'll have the integral of tan x with respect to x. Now when we come on to integrating 1 over 2 minus y, I'll just put the half there though first of all. When we come to integrating this, what we have is a fraction, and anytime I have a fraction, always check to see whether differentiating the denominator gives the value on the top or a constant times that value. Now if it does, it means that it's a natural log type. So if I differentiate the denominator here, I get -1, and so I basically got -1 times 1 here, so I can make an adjustment for that, and this becomes minus the natural log of the mod of 2 minus y. Okay? Similarly, when I integrate this, I just check out that differentiating the denominator here with respect to y gives simply 1, and that's in the top here. So this will be a natural log type as well, the natural log of the denominator, so that's the natural log of the mod of 2 plus y. Okay? Let's just square that bracket off there. Now when it comes to the integral of tan x with respect to x, you should know this one. It's a standard integral. It's in your formula book, so if you look that up you'll see that it is the natural log of the mod of sec x. Don't forget the constant of integration plus c. Now we need to work out this constant, so we can use what we're given up here to do that. So I'm just going to write that in, that when y equals 0 we're told that x equals pi upon 3. So if I substitute y equals 0 into here, what we've got is a half of, now putting 0 into this, we just have minus the natural log of 2, okay, and here we have plus the natural log of 2. I don't need mod signs anymore because these values are positive quantities, so just close that bracket off there. And then when I put pi upon 3 in for x here, we have the natural log of the mod of sec of pi upon 3 plus the constant c. So I'll just move this up. Okay, let's just leave that up here on display. So what have we got here? Well, when you're dealing with natural logs, or logs anyway, when you have the natural log of one value minus the natural log of another value, you can use the subtraction rule for logs, and that is that you get the natural log of one value, 2 in this case, over the 2 here. So that is the natural log, in fact, of 1, and we know that the natural log of 1 is 0, which I'm going to put down on the next line. What about over here? Natural log of sec pi upon 3. Well, pi upon 3, or I should say sec, sorry. Sec is 1 over cos, and the cosine of pi upon 3, I always like to think of it in degrees, I must admit. So I'm thinking now the cosine of 60 degrees is a half. So I've got 1 over the cosine of 60, 1 over a half, which is 2. So we have the natural log of 2 here. I don't need a mod sign for that either because it's positive, plus c. Now, I was saying earlier that this is natural log of 1 and that's 0. So we have 0 here equals natural log of 2 plus c. Rearranging this, I now have c equals minus the natural log of 2. And I can put this in this equation up here. So therefore what we have is half, and I also want to simplify this at this stage. Remember, if you have a log minus another log, this is the same as saying, in this case, the natural log of 2 plus y all over 2 minus y. And don't forget that mod sign down there. It equals the natural log of sec x. Okay, we'll put that in mods, plus the constant. Well, the constant is minus the natural log of 2. And what I'm going to do now is just simplify this further. I'm going to group together my terms. Okay, I'm going to actually use the power rule for natural logs. This power half can go up to the top here, and this becomes the natural log of 2 plus y over 2 minus y all to the power half, alright? Which is the same as saying the square root of all of this value. So just do that. And here we can use the subtraction rule for logs, and that becomes the natural log of sec x over 2. Now because I've got natural log equals natural log, I can remove the logs and I get the square root of 2 plus y over 2 minus y equals sec x over 2. I can see I'm nearly there now to get sec x in terms of a function of y, or sec squared x we're asked actually. So if I multiply both sides by 2 and square both sides, what I'm going to get is sec squared x. Remember, this will be 4, and if I multiply by 4, I'm going to get equals 4 multiplied by 2 plus y all over 2 minus y. Alright, and so we have sec squared x equals some function of y. And that brings us quite nicely to the end of this question.